All right, Calc, we are back for video number 2 here. Folks, you're just evaluating each integral. You have a definite one, so just take the antiderivative and then plug 2 in for x, minus when you evaluate for 1. All right, when you plug 1 in for x. There you go, folks. Take the antiderivative and plug 3 in for x, and then when you subtract, plugging in is 0, and you subtract that, it's going to be nothing. So just plug 3 in for x, 168 over 5. Take the antiderivative here, you get x minus 1/10 x to the 10th. Just plug 1 in, you get 9 over 10. Now, here's where you want to use U-Substitution. You do not want to have to multiply 1 minus x 9 times. So let u be 1 minus x. You could change the bounds here. We could change it later, or resubstitute 1 minus x in for u. Then that means the du is going to be negative x dx. I just want dx there, so dx is negative du. This is now going to be negative u to the 9th du, evaluated 0 to 1. So take the antiderivative, u to the 10th divided by 10, the opposite there. Again, I'm going to plug in 1 minus x in for u, and then evaluate at 1 and 0. When I plug 1 in, folks, I'm going to get 0. Right there, 0. Minus a negative 1/10 times, when you plug in 0, this is going to be 1 to the 10th, which is 1. Negative times a negative, or just subtract the negatives to add. So you get actually 1/10. Folks, here is not U-Substitution. Just, I don't know why I have equals here, folks, but it's not supposed to be there. Anyway, just divide by x. You have x to the negative 1/2 minus 2x. Okay, 1 power up divided by that power. And then plug 9 in and plug 1 in for x, and I believe you get negative 76. 32, again, just take the antiderivative, so it would be negative cosine, and instead of multiplying by 3 pi, you're going to divide by 3 pi. And then plug 1 in, negative cosine of 3 pi, that's the same location as pi, so that's actually going to be a negative 1. So negative 1 times negative 1 is just going to be 1 over 3 pi, minus, plug 0 in. When you plug 0 in, you're going to get 1. But then you're going to have, minus a negative 1, which is going to be plus 1 over 3 pi. That's 2 over 3 pi. All right, the other two we'll try in class. All right, again, you can't have all of them here. Only got so much time. 35, let's do some U-Substitution. If you let u be sine x, then du is cosine x, and then everything is accounted for. Then it's just the integral of u du. It's going to be u squared plus c, so plug sine x in for u, and there it is. That's an easy one. Folks, as I told the students in class Monday, get rid of the bounds here. Get rid of the bounds, so it's just indefinite integral. We're going to let u be 2 minus 3x. That means du is negative 3 dx. I just want it to be 1 dx. So divide by negative 3. That means dx, which is what I'm looking for, is just negative 1/3 du. So put the negative 1/3 on the outside. Again, get rid of the bounds. It's my fault. 1 over u, which is negative 1/3 natural log u, absolute value. Plug 2 minus 3x in, and then plus c. Get rid of the bounds on that one. Here, there's no bounds. Let u be the denominator, 1 plus x to the 4th. Take the derivative. So what I want to substitute something in for is x to the 3rd dx. So just get rid of the 4, divide both sides by 4. So now I have 1/4, 1 over u du. That's just the natural log. 1/4 natural log u plus c, and plug 1 plus x to the 4th in for u. This one, folks, you're going to let u be 1 plus secant theta. And the derivative of u would be secant theta tan theta d theta. All right, everything kind of cancels out, or, gets substituted pretty nicely, and that's how there should be an absolute value after the theta. All right, we've done this one before. U is the square root of x. So du is 1 over 2 root x. I just want 1 over root x dx. So I'm going to multiply both sides by 2. Again, I want 1 over root x and then dx. So that's 2 du right here. Antiderivative is just going to be 2 e to the u plus c, and then plug what u is, or square root of x is u. And then here, folks, okay, you might have to think about this one a little bit, but I really like this question. Let's let u be the natural log x, because the derivative of u is 1 over x dx, which takes care of this. That means you're going to have cosine u du. Antiderivative of cosine is sine u plus c. You have an indefinite integral. and u is natural log x. Lovely questions those are. Folks, this is just the fundamental theorem of calculus part 1. All right, I want to take the antiderivative. I want to take the derivative of an antiderivative. So if I go from a to x, I just plug x in for t, and I take the derivative of that upper bound, which is just 1. So it's literally that f prime of x is 1 over, or the square root of 1 plus x to the 4th. On 42, I do the same thing. I plug cosine x in for t. All right, but then that's not just a single x, that's cosine x. So I have to take the derivative of cosine x, which is negative sine x, and that's how we get that. We have done this question before. Plug x squared in for t, and then take the derivative of x squared, which is 2x, and that simplifies to be that. And 44, plug 2x to the third in for t twice there, and then take the derivative of that upper bound, which is 6x squared, and that cancels out to be that. Okay, you're probably going to have 2 of those questions. I would expect to have 2, or, yeah, I would expect to have maybe 2, 3. These are all day 2 questions, 27 to the end. Find the area of each region between the curves. So set, those 2 are both set equal to y, so set them equal to each other. Okay, which we... Well, I'm sorry, why do we not do that? Because I'm already given bounds, negative 1 to 2, negative 1 to 2. So the bounds are negative 1 to 2. We've got to figure out which one is going to be y top. Negative 1 to 2 means 0. Plug 0 in. That means this one's going to be 1, that one's going to be 9, that one's going to be y top. That's why it's first. You're subtracting all of that. So clean it up like that. Take the antiderivative as such, and then plug 2 in for x and negative 1 in for x, and subtract them. And you're on your own for that answer. We'll make sure to talk about that one in class. Here, folks, here's where you want to set them equal to each other. All right, you're going to get x is 0 and 1, so you have the bounds, 0 to 1. We need to figure out what y top is and y bottom. Well, 0 to 1 for bounds means, let's use a half. Plug in a half for x, you get a half. If you square a half, you get a fourth. A half is bigger, so that's going to be y top. It's going to be x minus x squared. Take the antiderivative and plug 1 in, and then plug 0 in, you get a 6. 47, let's let this be x equals 1 minus y, set them equal to each other. All right, we've done this one before. You get negative 1 and 1/2 for the bounds. Let's figure out what, x right is. Negative 1/2 to 1, that means plug 0 in. This is going to give you 0, and that's going to give you 1. So this one goes up top, and you subtract the other one. You got to make sure you get those right. You're going to get opposite answers. All right, and then evaluate it, and, well, you're on your own for that one. We're going to do 49 next. They're both set equal to x, set them equal to each other. You get y is plus or minus 2. Those are the bounds, so plug in 0. If you plug in 0 here, you're going to get 0. Plug in 0 there, you get 4, so that's going to be x to the right. That's going to go first, and you're going to subtract 2y squared. Clean it up a little bit. Take the antiderivative, plug 2, then negative 2 in. This was actually, I believe, on your last quiz. All right, they're both set equal to y, so set them equal to each other. You get plus or minus 3 for the bounds. Those are your answers to x. Plug 0 in, you get 12, negative 6. So this is y top. It goes first. You're subtracting all of that, so it's going to be positive 18 minus 2x squared. Plug in 3, then negative 3 in, and this also looks very familiar. All right, I would expect 2 of those questions. Evaluate each limit, L'Hopital's, most likely. I'd expect a good amount of these. All right. You have a 0 over 0 case, so take the take the derivative of the top, that's e to the x, take the derivative of the bottom, that's 3x squared. You would think to do it again, but folks, technically, if I plug 0 in for x, I get 1. 1 over 0 is not a 0 over 0 or infinity over infinity case, so that makes this one undefined. Okay, I like that one less. This is another 0 over 0 case, plug 0, or take the derivative of the top and the bottom. Now, when I plug 0 in for secant and cosine, I get 1. So this one, I only have to take the derivative 1 time. Here, I don't really need to use L'Hopital's. I could also just factor it. 54, to use L'Hopital, you have infinity over infinity case several times. You got to do it a few times. You can still get an answer of infinity, but this proves it. Now it's infinity over 6 instead of infinity over infinity. Folks, you have to have a fraction to use L'Hopital's. It's got to be something over something. So e to the negative x squared would just be 1 over e to the positive x squared. You have the infinity over infinity case a few times. Do a little algebra. Then you get the 3 over infinity, which is 0 solution. Guys, cotangent of 2x is just 1 over tangent. Okay, take the derivative. You you get 6 cosine 2x. And then at the bottom, you get 2, you get the secant squared of 2x and multiplied by 2. Anyway, when you plug 0 in, you're going to get 6 over 2, which is 3. We'll talk about that one in class as well. Here, you get the 0 over 0 case. So use L'Hopital's rule, take the derivative, 1 over x. At the bottom, it's going to be cosine of pi x times pi. So that means x goes at the bottom. You let x be 1, you get negative 1 over pi. Here's a little bit of a tricky one, but you use L'Hopital's twice because you get a 0 over 0 case twice. And then that's a little messy. We'll try to talk about that one in class. But it does come out to get a reasonable answer. And then lastly, folks, here it's just 1 over e to the 3x. And that's just going to be 0. It's 1 over infinity. Here you use L'Hopital's a few times. You get 6 over infinity, which is 0. Here we got the 0, 0 case. You use L'Hopital's just once because you get 0 over 1, which is not a 0 over 0 or infinity over infinity case. That's just 0. And then on 62, you have the 0 over 0 case. Use L'Hopital's. All right, so when I actually plug 1 in, I'm going to get just pi because secant squared of 0 is 1. And then at the bottom, it's just going to be 1 over 1. Your answer is just going to be pi. Folks, that is video number 2. You have pretty much all the answers for your review. Thanks to Ultra, Chinatown, and Coffee Espresso. This is Yak Math Videos, signing out.